Yeah, thanks for joining me. So I want to present this work, which is quantifying data sensitivity. Sorry, I can't move everyone's face. I need to move it out of the way. Quantifying data sensitivity, precise demonstration of care when building student prediction models. This is some work that I did with a couple of people, one who was in Canada, Jean Sinclair, and then Charlotte Wu over at Stanford. Just wanted to start off by saying we have talked about, for like 10 years talking about the explosive rate of data collection in educational settings, but like in the last week, now we really know what explosive rate of change in data collection looks like. This is a graph out of Google Classroom a principal sent me this week, showing like a 5-fold increase in the number of online classes at this public school in Brooklyn as everyone went into lockdown. So yeah, explosive rates of change in data collection are kind of all relative, and now we know what it really looks like when it goes up. Against that kind of backdrop, we've had about 5 years of this discussion with a bunch of people saying, well, more data is better. It means that we can do like more accurate predictions. We can get very rare cases and have a better understanding. And a substantial amount of the kind of idea behind learning analytics, I would say, comes from this idea that we have got access to new and more data. But on the other side, there's been, people saying that, there's a bunch of dangers that come with more and bigger data sets, and that we need to be mindful of this. And there's not a huge amount of kind of movement on either side, I would say. So what this is about is like kind of coming up with a way to move forward just beyond this antagonism between these two sides. And one of the ways that we have been thinking about this and trying to push this forward is this idea of data collection parsimony that we've stolen from conservation science, where in that world, taking measurements, every measurement you take of an endangered species can risk that species. So adding, trackers to animals can hurt them, or being too close to a population can stop them from breeding. So they have this concept of data collection parsimony that is about collecting the minimum amount of the least number of features that will have the least impact on the species under study. So we think, well, maybe there's something in that we can use because our species under study, which is students, often it would be good to demonstrate a level of care and to demonstrate that, yes, actually we are taking into account the dangers of doing the work that we're doing to their educational experience. The issue that we have is this idea of least impact. It makes sense. Minimum amount we can kind of get our head around. We'll just, collect the data you need, not like everything. And then same for the minimum number of features. But the idea of least impact is actually really tricky. It's this idea that is data, kind of often called data sensitivity in other fields. Unfortunately, sensitivity already has a statistical meaning that's often used in learning analytics, sensitivity analysis of models and things like that. That's not what we're going to mean here when we say data sensitivity. What we mean is least impact of the analysis that we're using. But yeah, these are the words that we've been handed down from our elders, so we've got to kind of navigate that confusion. But data sensitivity it's a slippery, tricky concept. It kind of makes an intuitive sense at first, and then you spend a bit of time thinking about it, and it becomes harder and harder. We've got this and that kind of is borne out in the kind of work that people do. They concentrate on anonymization rather than looking at this sensitivity thing. Like we've got quite a robust amount of work on how to anonymize data so it doesn't, so that we don't know who we're looking at. But we've got a lot less on the actual how to measure the impact of that data on those people. And although that we might not be studying it, the institutions have found it necessary to try to take a swing at this and create tables like the one on the right, which is a classification table of different types of data and how sensitive it is. You kind of have two ways of doing this. One is to get a committee of experts together and they decide, which seems to be what a lot of institutions do. And the other way that people have looked at is actually getting the opinion from the population whose data is being collected and using that to develop some kind of sensitivity structure. We looked at about 25 different higher education institutions. We didn't find any that explicitly said that they were including the student's voice in the definitions in the classification systems for data, which is kind of interesting. And we think maybe there's something there that we can work with. We're not the first people to try to do this. The knowledge discovery community in the early 2000s was interested in this problem and they didn't really come to a resolution. They were explicitly interested in the educational setting, but they couldn't really figure out which was preferable, the kind of expert route or the student opinion route. But we think maybe the student opinion route, there's something in it. The other issue is that if you want to go the way of asking people how sensitive they think data is, it's how to scale it. And kind of the legal scholarship is an interesting example in that they've kind of gone full circle where they started off having a binary, something is sensitive or something is not sensitive, up until about the late 80s, early 90s. And then they decided that that didn't capture sensitivity well enough, that there were kind of grades of sensitivity and they should be trying to look at those grades. But then in the 2000s, they moved back to a binary system because the graded system didn't seem to, it had a bunch of problems. One of which is that if you give people a choice of graded systems, they tend to kind of pick the extremes anyway, so it kind of doesn't matter. But on the right here, you've got a bunch of examples of the kinds of scales that people are using. GDPR has a kind of binary system, but the UK Privacy Commissioner, I guess they always have to be different. They have 10 separate categories, and then universities kind of have a range as well. Kind of the part of the issue in developing these scales is that it's really this highly dimensional character to sensitivity. You've got a bunch of variation that can go across features like we've been talking about, but you can also go across students. So just because one student thinks a particular data point is very sensitive, that doesn't mean another one will. And then that may change over time. You can imagine that if a student becomes ill with a disease, suddenly certain data fields become much more sensitive for that person. We can see this on the right. We collected a bunch of data from respondents on how sensitive they thought different data fields were. And you can see that although there are kind of trends, so people seem to think for some reason that student ID is on average probably more sensitive than gender. That doesn't mean that there aren't people in there who think that gender is very sensitive to them particularly. So part of this is that a lot of the administrative categorizations tend to want to be very deterministic. So a particular data field is of a particular sensitivity and it will always be like that. rather than moving to a kind of probabilistic model. So what we wanted to do here was to take the scale and try to make it maybe a little bit more probabilistic, try to capture this variation across these different dimensions a little bit more. And the context that we did this work in was building predictive models. That seems like a useful context. And when we develop new models, which it seems like models don't really travel across institutions that well, so institutions might be developing their own models as they go along to try to predict things like dropout, that they should be taking into account sensitivity as they do that. Over here we've got the kind of basic model building process. We take in data, you develop your model, and then you have this evaluation period. And we think that as part of the evaluation period, where you're looking at a bunch of different models for accuracy metrics, that it would work well to slide in there actually a comparison of models on data sensitivity and evaluate them for their data sensitivity or their impact on students, to demonstrate that you actually care about what the students think of your model before implementing it. And you can really surface the trade-offs between privacy and having a very accurate model, or having a model that does something that is useful to you, and how much that is going to impact the population that you're working with. So the way that we did this was that we went with a binary sensitive, not sensitive definition, but then we calculate a probability of the feature being, of a given data field being sensitive, and we treat that as a random variable. And this has a bunch of benefits in that what we're really saying is that students can kind of move around within that probability distribution, but the overall form of the distribution will stay the same. So although some students may become, a certain data field may become more sensitive for a student, the kind of overall number of students that has that opinion of that data field will remain kind of fairly stable and in a given time period. And then we can also then use Bayes' to calculate the overall sensitivity for a given model that includes a bunch of different features in it. And that's what we did here. So we had this analytic strategy to take a data set with lots and lots of variables and then grade those variables for their sensitivity, and then generate a bunch of different models predicting some aspect of that data, and then look for patterns between the overall sensitivity of those models and the kind of accuracy metrics, and then try to figure out, well, how many types of variables could we get away with? What's the minimum number of sensitivity questions that we'd need to ask in order to make these calculations kind of reliably? The data that we used was the Ontario Secondary School Literacy Test, and the reason for that is that it had attached to it, it wasn't just a test, it had 43 other variables that ranged across kind of medical conditions to like how much TV students are watching. So there's like a huge range of types of variables. And then we got a bunch of Amazon Turkers to rate those variables on their sensitivity across those 44 categories. And then we used the variables and across a bunch of different models to predict whether a student was going to pass or fail. And then we generated the accuracy metrics for all those models, and also had a sensitivity metric, a probability of sensitivity for each of those models. And so this is what it kind of looks like overall when we compare against different ways of measuring data sensitivity. So this first table kind of, the first thing it shows is that like the categorical way of measuring stuff is quite difficult to interpret. So it's kind of hard to tell, hard to compare the last and second last model. What does it mean to have 14 level 3 variables in your model versus 14 level 2 variables in your model. That's kind of a hard thing. So collapsing all that down into one metric seems to be a useful thing to do. And we also see that kind of there is a correlation between the number of features that you use in a model and its probability of sensitivity. And that is not really much different between whether you just use the total number of features and whether you count up how many binary features there is. When we move to like compare across accuracy metrics, so do the evaluation metrics screen for data sensitivity? Here we're interested in saying, well, maybe just doing the regular evaluation metrics actually gets rid of models that don't that are highly sensitive anyway, so it doesn't really matter and we wouldn't need to do this. And the answer to that is probably no. It just seems like highly sensitive and highly accurate models can exist, which, you know, maybe it was obvious, but now we've shown it. The next question is a little bit more tricky. It's that is just counting the number of features in your model a good proxy for data sensitivity? And the answer there is kind of maybe. We'd probably need to do more tests. So yeah, there is this relationship, but it's hard to tell just from this data how like whether that's a predictable relationship. It kind of maybe looks exponential, maybe. It's certainly not linear. But yeah, so we'd have to do more tests to figure out if, oh, maybe we could just use the number of features in the model as a good proxy, and we wouldn't actually have to survey anyone, but that would be a useful piece of information to know. The last thing we wanted to know was, we got a bunch of people on Amazon Turk to rate these, and we made them rate 44 different categories. That's probably not a practical solution for any educational institution to do. So we wanted to know how many different types of categories was kind of like, what's the least number that is possible. And we came up, the way we did this is that we used some hierarchical modeling to use the patterns of correct and incorrect across the questions and the kind of associations there to categorize the different, to categorize all our features into 50, 40, 30, 20, and 6 categories. If we go below 6, if we go down to 5 categories, then the whole thing really just breaks down. So what we kind of think is that the minimum probable number is about 6 or 7 that you could get away with, which doesn't seem too onerous to ask people. It's probably, yeah, that okay. Certainly there are limitations like surveying students, but maybe we could repurpose other data that we already collect. A lot of places ask already for releases on putting pictures and other information on their websites. In the US, you have to, all students have to sign a form about what information they will allow other students to see. In terms of other limitations, though, here we haven't really taken account for time. Time is a big problem here. Things could move quickly. We don't know if you'd have to re-evaluate every semester or maybe even mid-semester, something like that. That could be a real pain. The other thing is we haven't looked at important groupings. So you can imagine that maybe the journalism school in a university and the engineering school in a university, those students would have very different ideas of what data is sensitive, and so you might need to build separate models for each school. But although we've looked at kind of model building, we think this could be useful for other analytic artifacts like dashboards. If you wanted to compare the sensitivity of different dashboards, you could use the same process. If you wanted to use it as a way of monitor or allowing different people to see different dashboards, because different dashboards have different levels of sensitivity, that is a possibility. I think that is it. I think, the bottom line here is that we think the learning analytics community should be doing something like this, even if it's not this exact way. That we also think that treating sensitivity as a random variable has some conceptual advantages for aggregating comparisons, and it combines the kind of binary collection and the continuous metric, and it kind of neatly collapses a lot of the dimensions into it in a tractable way. Kind of bottom line here is that we think need about 7 categories of data to do this, but that it's it's good for you, and that we should be we talk a big talk about doing things responsibly, but this would be one way that we could kind of eat our own broccoli. So thanks, that's all I've got. Open to questions.